Bismillahirrahmanirrahim. Viewers, today we will talk about a special type of structure is stack, an abstract data type. A stack is a list of elements in which elements may be inserted or deleted only at one end, and that end of the stack is called top end or top of the stack. The elements are removed from the stack in the reverse order, in the order in which they were inserted to the stack. That's why stack is also called last in first out structure. Shortly we can say it LIFO structure. As example, we can say that stack of dishes, stack of books, and stack of folded towels. Stack is normally consist of two basic operations known as push and pop. Push is a term used to insert an element into a stack, while pop is a term used to delete an element from the stack. Let's see at the figure. Suppose this is a stack having four elements A, B, C and D. So A was inserted first to the stack. After A, B was inserted to the stack. After B, C was inserted, and after C, D was inserted. So top element is a D. D is an element which is stored at top of the stack. Now if we want to delete element from the stack, so we can only delete D first. If we want to delete C, we cannot delete C without deleting D. The element which will delete it first from the stack is D. So after deleting D, we can delete C. Then we can delete B. Then at the end we can delete element A. So that's why we can say that the elements are removed from the stack in reverse order, in order in which they were inserted to the stack. The order of insertion was A, B, C and D, but the order of deletion is D, C, B, A. So which is totally reversed to the order of insertion. So this is called stack. This is a special type of structure. Stack has only one end. We can imagine of the stack is a container having one open end, which is, and that specific end is used for both insertion and deletion. So we don't have any other end to deal with data. Representation of stack in computer memory. Basically, two methods can be used to store stack during programming in computer memory. These are array-based memory representation and pointer-based memory representation. Based memory representation, or we can say it linked list based. So these are the two methods which can be used to represent stack in computer memory during programming languages. So during array-based memory representation of stack, one-dimensional array can be used. One-dimensional array can be used. Array can be used, and the number of location in array representation is fixed. As you know that we know that array is a static structure, so where number of the elements are fixed. For example, if you want to store 10 integer item in the stack, then you need to define an array of length 10, and the type of the array should be must be integer. So we can write it as int stake. Suppose we are using name for the stake is stake 10. So through this statement we can define an stake in computer memory which will hold 10 integer values. It will reserve a memory, a block of memory, as we know that array is a contiguous memory location which stores contiguous memory locations to store homogeneous data elements. A block of memory which reserve a block of memory to store the items of same data type. And along with this we need to define a pointer variable known as top, which will indicate the top element of the stack. Initially if the stack is empty, so the value of the top will be 0 or null. This is the condition which shows that stack is empty. And along with this we need to define another variable we can naming as max stack, which will indicate the total length of the stack, the total length of the list. As in our example we defined the length 10. So this variable will help us to print the overflow message. Let's see array based stack operations, which are push and pop. Let define the logic to push element to the stack, and similarly the logic to pop element, to remove element from the stack. Let's see, our first operation is push operation. As we know that push operation is refers to the adding of element to the stack, the operation of inserting element to the stack. So there is a very simple logic behind pushing an item to the stack. That is, first we need to get new data from the user, and second, at second step we will store that data at the top location of the stack. So let's define this idea through pseudocode. So this is the simple logic which we can use to push item to the stack. The first statement we used here to check overflow message. If stack is full, then we cannot add a new element to the stack, and this condition will be true when the top will become equal to the max stack. As we know that max stack is already defined, which represents length of the list, and top is a variable which indicate the top element of the list. So at first step we will this statement we can check whether there is space, empty space or not. We can check that whether the list is can hold a new element or not. If top become equal to max stack, so this will print the message of overflow message. There is no space to add new element to the stack. So if this condition is false, as you know that this is a decision structure, if this condition is false, so it should start to the next step. Before adding the item to the stack, first we need to update the top element. We need to shift the top to the free space which we can achieve by the statement top is equal to top plus 1. And after this statement we will put the item, our item which we want to insert to the stack, at the top index of the stack. As we are representing our stack through array, so this syntax is used for array. As you all are well aware of this statement, that is, this is name of stake and this is an index number. So this item will be inserted at this index number of the stake. So through this simple logic we can add item to the stake. Let's see it through an example. Suppose we have a stake, a small stake. Let's draw a small stake. Which can hold only 4 elements. So this is a stake. So initially if we put that stake is empty, so top is 0 and max stake is equal 4, means this stake can hold, this list can hold 4 elements. So now let's see what happened if we run this these statements. If top is equal to max stake, top equal to max stake, no, so this condition is false. So this statement should be run. This statement says that set top is equal to top plus 1, so 0 plus 1 equal to 1, so top become equal 1. So now top represents this location. So at the other third statement we say that set top one item. So this item, suppose the item is 10, so the 10 will be stored at index 1 of the stake. So suppose we want to run this statement again. So again we can check here, if top is equal to max stake, is top is equal to 1 and max stake is equal to 4, which is constant. Top 1 is equal to 4, no, so this statement is false. Second, set top is equal to top plus 1, again top will become 2, 1 plus 1 2. So now top is representing second index, free space. Set stake top item, suppose now our item is 15, so this 15 will be stored at second location. Similarly again 2 is not equal to 4, so we can add another item. So top will become equal to 3 and the third item, suppose this is 20, will be stored at index 3. After that, if you want to add another item, so 3 is equal to 4, no, 3 is not equal to 4, again this condition is false. So top is equal to top plus 1, 3 plus 1, now top will become 4 and our fourth element, suppose this is 25, will be stored at fourth index of the stake. After that, as you can see here, now stake is full. Now this statement will not allow us to add new item to the stake. Suppose we want to store 30, so now the value of top is 4 and max stake is 4. Top is equal to max stake, yes, top is equal to max stake, so this will print overflow and exit, means there is no space to add new item to the stake. Now let's see the pop operation which we can which we can perform through this simple logic, as you can see here. Students, before explaining this, the possibility is that stake may be empty by the time of deletion, if we want to delete item but stake is empty. So therefore it is important to check whether the stake is empty or not. So this check can be implemented with the very simple statement as shown here. This is if top is equal to 0 or null, then print underflow and exit. As we say earlier that top equal to 0 means stake is empty. Stake is empty. If initially stake is empty and we want to delete, we want to perform pop operation, so this operation will be activated and it will print us that underflow. Underflow means there is no item to be deleted. Second thing, you need to remember that as we know that data can only be deleted from the top of the list, so it is not required to check or ask user for any information in this case. So the operation can be implemented with the following C statement. We don't need to ask user, don't need to read location of the item which we want to delete, as this is stack and only the top element will be deleted from the stack. So this statement shows that we need to select the top element of the stack. Set item stack top element, we need to select the top element of the stack. We don't need to read item from the stack or location of the item item of from the user to be deleted. We need to we will delete only top element of the stack. So this statement shows that we will select the top element of the stack to delete. So the delete operation can be performed by the simple statement by decrement the value of top by 1. Set top is equal to top minus 1. This statement is used to delete the element the top element of the stack. If top represents, suppose if top represents 5, so this statement will decrease top by 1. Now top will represent 4, means that the element stored at the location 5 has been deleted. So let's see here. Suppose we have a stack with length 4, which can hold 4 elements, but currently this stack has 3 elements, 10, 15 and 20. So top is equal to 3. It means that 10 was inserted first, 15 was inserted to the stack after 10, and 20 was inserted to the stack at the end. So suppose we want to operate pop operation on the stack. We want to delete element from the stack, so only the according to the definition of the stack, the top element should be deleted. So the top element is 20. Let's see our designed algorithm, how it works. If top is equal to null, this is just a check whether stack is empty or not. No, stack is not empty because top is 3. So set item stack top means this statement shows that you need to select the top element of the stack. So 20 will be selected. So set top is equal to top minus 1. This statement shows that top is equal to top minus 1 means top minus 1, 3 minus 1, 2. So top will become equal to, now it will decrement top by 1. Now top will indicate this element, so 20 has been deleted. So similarly again we can run this statement again. Let's see, if top is equal to null, no, top is not equal to null, top is 2. So set item stack top, so 15 will be selected, and set top is equal to top minus 1, 2 minus 1, it will become 1. Now top element will indicate the element stored at index 1, that is 10. It means that 15 has been deleted from the stack. Similarly, suppose once again we run this operation. Top is equal to null, no, top is not equal to null because top is 1. So set item stack top, then select the top element of the stack and set top is equal to top minus 1, 1 minus 1, 0. It will become 0. No, as you can see here, we don't have an index labeled as 0. So after that, if again we want to run this element, let's see what happened. Top is equal to null, yes, null means 0, yes, 0 is equal to 0. So it will print the message underflow, means stack is empty, you don't have any item to be deleted. So this was the simple method to perform pop operation on the stack. Similarly, we can perform both push and pop operation parallelly. You can you can write a C program or any other language program to perform the push and pop operation on stack. randomly and parallelly. So if you want to perform push operation on the stack, so once again it will start from the 1. The new element will be inserted at index 1. Similarly, the second element will be inserted at index 2, and so on. Thank you so much.